Test-driven development is mentioned in the Accelerate research as one of the technical practices that drives adoption of continuous delivery. That means that elite performers, the ones who are really good at software development, are doing this. Now, the kinds of organisations that I often work with are more aspiring to continuous delivery than actually doing it yet. And it's rare that I meet anyone who really understands what TDD is, let alone practices it. And it's sad because I found TDD to be an essential tool for tackling complexity in software development, increasing the quality of the code I write, and making my life less stressful. In this learning hour, I'd like to show you what it is and how learning TDD could make a difference in your work. This is a guided learning hour, and that means this training is designed to be done together with the other people in your development team. If you haven't done one of these before, you should look at my video, Guided Learning Hour How To. I also have a Patreon, and through that you can get access to the online whiteboard that I'm using in this video, and other exclusive subscriber benefits. So, pause the video while you gather your team. Hello everyone, I'm Emily Bache. In this session, we'll be learning about test-driven development, what it is and why you should care. We're working in this online shared whiteboard. My opening question today is, so what is TDD like? I want you to write your ideas on notes. How would you spot if somebody was doing TDD? Okay, so I don't know what you've written, but perhaps you didn't know very much about TDD yet, or perhaps what you do know doesn't turn out to be quite accurate, because I think there's a lot of myths and misunderstandings about test-driven development. There was this study a few years ago where they actually asked a bunch of Java developers to all install this IDE plugin that meant the researchers could track what the developers were doing in their tools, and they could come up with a kind of a sequence like this graph here where they can see they started the IDE, they wrote some code, they wrote some tests, they ran the tests, they failed, that kind of thing. And they were using this data to look at whether people were doing test-driven development. And they also asked them beforehand, are you doing test-driven development? And some of them said they were. But unfortunately, the results were a little bit disappointing because they found that less than 3% of the developers in the study were actually doing TDD. And less than 20% were ever running any tests at all. So it seems that test-driven development is not that widespread. And actually, this was a bunch of Java developers in 2015. I don't think I have any reason to believe it's that different in most other communities of developers. And this is kind of a shame because TDD is actually a really, really useful thing to be able to do. There was this research that came out, other research, by Nicole Forsgren and a bunch of other well-respected people, looking at the best organizations, the ones that are elite performers, that are really good at delivering very high-quality software frequently, and getting features out to their users. And one of the things that they found in this data was that continuous delivery is associated with this kind of success. And the organizations that were doing continuous delivery were also doing TDD. They said automated tests in these organizations are primarily created and maintained by developers, and developers practice test-driven development. Of course, there's more to it than that. There's a bunch of other stuff these people are doing, but TDD is in there. And one of the persistent myths about TDD is it's somehow to do with testing and testers do it. This is something developers do. All of these books are written by experts in writing good tests, and they're not testers. These are developers. These are my heroes, the people who I've learned this technique from. And these are some of the best developers in our industry. So I think if you're aspiring to be a great developer, it could be a good idea to learn this. So lots there on why this could be a good thing to learn. If you know anything about TDD, you've probably heard of the TDD cycle: red, green, refactor. Write a failing test, see it pass, improve the design. One of the things that happens when you work this way is it reduces your stress. You're just focusing on one thing at a time, and you can put the rest out of your mind. I'm just refactoring now, or I'm just trying to design a test case. Too often when you're developing, you've got loads of things in your head at once, and that can make you stressful, where I find TDD kind of benefits me as a developer. And the other thing about this is because you're a bit less stressed, you're better equipped to tackle complexity. And software development is a complex activity. So with TDD, you can actually tackle more complex problems than you might otherwise be able to do. That's my experience, at least. Let me show you a demo. Okay, so let's take a look at test-driven development in practice. I'm going to develop a small piece of code using TDD in the Rider IDE with C#. Try not to get too hung up on the details of the programming language or the test framework. What is important here is the way of working. Small steps, always knowing if you expect the tests to pass or not. This is the code kata I'm going to work on. It's the leap years kata. Write a function that returns true or false depending on whether the input integer is a leap year or not. Then it gives you the rules. A leap year is one that's divisible by 4, but not otherwise divisible by 100 unless it's divisible by 400. And then it gives you a bunch of examples. For example, 2001 is a typical common year, and so on, more examples. So that's the coding problem I'm going to try and solve for you using test-driven development. So on the left, I've got some code there. That's a unit test that doesn't test anything particular. In fact, it fails. And I like to start with just a failing test to check that my tools are working, and I can just fix that so that it passes by changing that false to a true. And that just proves to me my tools are all set up. So now I'm in a position to do some actual interesting work. So when I'm starting with test-driven development, I like to start with some examples. And this code kata comes with examples that are very easy to turn into a test list. And I'm just going to use a comment in my test file to keep track of my test list. Some people put this on a piece of paper, but for this demo, it's kind of convenient to have it actually in the editor. So I've got 4 tests in my list, actually, and there's examples that I'm going to turn into tests. These are 4 years that come from the problem description. Okay, so I should start by writing a test for a typical common year, like 2001. So I'm going to use that language from the problem description in my test name so that the names of the tests are going to describe the different scenarios from the problem description. So let's look at 2001 then. That is not a leap year, so this is going to return false. And then I need some kind of function that I'm going to call. And how about leap year and a function called isLeap that I can pass this input integer to, as it says in the problem description. So I've just done some design there. I've kind of decided that I'm going to have a leap year class with an isLeap function. And now I've written the test. I need to actually create those things so that the test will be able to compile and run. So I'm going to use my tools to create a leap year class and the isLeap method on that and make sure I get the signature right. The boxes here take me through it. Okay, so now I've got a not implemented exception as the implementation. Well, that compiles, I can run that. And of course it fails the test because I get this exception. And at this point, I like to just look at the failure that I got. Is that the failure I expected? Is my test failing because my implementation is wrong? Because that's what it should be failing because of. And it's clear in this case that that's what's happening. So I need to fix the implementation now. So I'm going to go to the green step where I'm going to try and write code that makes the test pass. Great. So that seems to have been successful. Just returning false is enough for the tests I've got. Of course, it's a stupid implementation generally. I mean, not going to leave the code like this, but with the green step, the impetus is to get the test to pass as quickly as possible, even if you have to take shortcuts and do stuff that isn't strictly good coding practice. But I'm not going to leave it like that for very long. But while it's green, I'm going to take the opportunity to do a little refactoring. I'm going to move this class to its own file. so that it's not in the same file as the test. Normally you wouldn't want your production code and your test code mixed up like that. Great, so that refactoring was successful. The test is still green. So let's go back and do something that will force us to do a better implementation than this. I can cross the first case off my list, actually. I've done the typical common year. Well, kind of. But let's see if the next test case will force us to do something a bit better. Right, so this test case is for the typical leap year. And for this one, it's going to assert that it's true. And we're going to put in 1996, which was a leap year. And now, so if I run this, I'm expecting it to fail. This is the red step of TDD. I've got a failing test, and I just want to check that it is the failure I expected. Yep, that's the one. And then I can do what I want to actually get this to pass. So I see in the requirements that a leap year is divisible by 4. And I know how to do that, I think. So I'm just going to do that. So if the year is divisible by 4, then it's a leap year, and otherwise it's not. And that bit of code is enough to make both my tests pass. So I've got back to green here, and now the next step would be refactor. But there isn't a lot of code here now. I'm mostly happy with what it's doing. I think I'm just going to cross that test off and perhaps go to the next one. So now we're on an atypical common year. And so this is kind of similar to this test. So I'm going to start by just copying this test. And we're going to just modify this so it's got a different name. The scenario is an atypical common year, and the year in question was 1900 from the examples we've got. Okay, so this test should fail now. Getting me back to the red step of TDD. Great, I've got a failure. It's the one I was expecting. And now I can look back. What is the rule here? It's, oh yes, it's divisible by 100. That's why this one was not a leap year. So I'm just going to put an extra condition in here to check for that. So that one is not a leap year. And when I run the test, I'm expecting them to pass. Great, got to green. And now again, I could refactor at this point, but I think I'm probably okay. I'm just going to cross that test off my list and perhaps go to the next one. Okay, so what's remaining here is the atypical leap year. And so I'm just going to start by copying this test, which is going to be kind of similar. And just modify the name again. So it's saying that this is the atypical leap year. And for this one, we had in the list, what was it? It was 2000. So I'm going to put 2000 in here in the right place. Make sure I'm modifying the right test. Okay, so this one is expected to fail now. Yes, there it is. And it's the failure I was expecting. So now I've got red. I can go and try and get to green. So this is the final rule here when it's divisible by 400. So I'm just going to put another condition here at the start of the function to check for this situation. If it's divisible by 400, then I can return true. Great. So now all my tests are passing. And let's see, I've got all the tests on my list now. So let's just cross that off and check. So at this point, when you get to the end of your test list, it's always a good point to kind of review where you are, take stock and work out, well, should there be something else on my list? Am I done yet? What does the code look like? What is in the spec? Have I forgotten like years before 17 something or other didn't have leap years? And should I include that? But actually, this is just a code kata and I've got to the end of the requirements that I've got. So at this point, I don't need my test list anymore. I've turned them into tests. But I did just spot here, actually, I didn't rename this test case. I should probably do that. So let's name this a leap year test so that it matches the name of the thing it's testing. That makes more sense. And of course, I should just run my tests again after that refactoring. Yep, we're still good. And now, since I'm kind of feeling like I'm pretty much done here, I should probably make a commit. And then I can share my work with the other members of my team. Okay, so you've just watched me doing a demo of test-driven development. And just to check if you were paying attention, I've got a couple of little exercises for you to do in small groups. So in this first exercise, there are 3 screenshots from the demo, and I just want you to match them up with the phase of TDD. In this screenshot, am I doing red, green, or refactor? And you can move the labels next to the screenshot. Hopefully that won't be too difficult. When you've done that, I want you to look at this second exercise, which is about the characteristics of TDD. How would you be able to tell if you were doing TDD based on the demo I just gave? So there's a little pile of notes in the corner describing things that a developer might do. And I want you to categorize them. Is that something that might happen in TDD? Or is that something that definitely wouldn't happen in TDD? And you can move the notes to either side of the line and have a little discussion. And if you find that you've discussed all of my notes and that you've still got time, you could go back to the notes that you wrote on the first board when I was asking you how you'd recognize TDD. And you might just want to revisit those. Can you put them definitely in the TDD compatible pile? Or are they things that you think now, actually, maybe that's not? I hope you have a good discussion about this anyway. Let's go through the solutions to these now. And I'm sure that this wasn't too difficult because you can see on the first screenshot, all my tests are passing. So that's either green or refactor. But in this case, that's green. The second screenshot, the tests are failing. So that's the red step. And in the third screenshot, I'm doing a refactoring. I'm moving a class to another file. So that's the refactor step. The second exercise where you had to decide if it was TDD or not TDD, I'll just go through these quickly as well. So in TDD, you do begin by writing a failing test. It's not a case that you finish the implementation and then start writing the tests. No, tests first. You shouldn't be refactoring when there are failing tests. That's not a sign of TDD. And you should definitely refactor before the end. It's something that happens potentially every time you go around the cycle. And if you leave it all to the end, you've probably left yourself too much refactoring at once. But what is compatible with TDD is thinking. So it's quite okay to spend a few minutes thinking about the code you're going to write before you write it. You don't have to write the test as absolutely the first thing you do. Thinking is always allowed. And you should try and just write enough production code to make a test pass and not more. If you write too much code in the green step, then you end up writing code that isn't covered by any tests and you don't get any feedback on whether it works or not. So this is kind of the characteristics of TDD. Now it's your turn. I think you should have a go at doing TDD on the same problem that I was tackling, leap years. I want you to start with an empty project with just like a failing test that you can then modify and work with to write the failing test that you want for this problem. I want you to work with a test list, either write that down or put it in a comment or just, some people just keep it in their head, but I do encourage you to explicitly have it somewhere. And then go through your list, implementing one at a time. And don't be afraid to modify your list as you go if you think you forgot something. Just now, at the end of the session, I'd like you to spend a couple of minutes noting down what you've learned. Write yourself a note in your own words. What would you look for if somebody told you they were doing test-driven development? How would you spot that? So I hope this session has given you some insight into what test-driven development is all about. I have a strong feeling that there will be more guided learning hours after this one to explain more. And I hope you'll join me for those ones too. In the meantime, happy coding! This part of the video is the facilitator's briefing, and that means it's intended for the person who's going to lead this session with their team. I've got some hints and tips and things that you want to think about when you're leading the session. If you want to get access to this shared activity board, you can get a copy of mine by subscribing to my Patreon. In this guided learning hour, there are 4 points where you're going to pause the video and do something with your team. And these are all 4C activities from Sharon Bowman's training from the back of the room. And there are time limits here for each part of the session so that you'll fit everything in. So one of your jobs is to keep time. In the Connect, your job is to basically repeat what I said and get people to write a note each. If they don't write any notes, you could prompt them, repeat the question again. And if people stop writing notes and your time limit is not run out yet, there's no need to just kind of wait for the time to run out. If you think people are done writing, then just move on to the next part. After the demo, you'll want to pause the video again for the little exercises that I've got. The kind of purpose of these is to make sure people were paying attention and get them to process what they saw. So I'd like you to do this in pairs unless you've got a very small team, so that people have more chance to kind of talk to one another and express what they've seen and learnt. And if people finish that discussion very quickly, they could look up what you wrote in the first exercise and talk about that. Is that really TDD if those things happen? Because, I mean, there's so much lack of knowledge about this in our industry, and it might be good for your team to have a chance to talk about that. What is TDD? Why would you do it? What is it for? But then, of course, I do want people to try out the technique for themselves. They've seen the demo, and I'd like them to see if they could do that as well. Remind people, though, not to write all the code at once. That is the biggest mistake I see when people try and do TDD. This is such a small problem. And you can, of course, just write all the production code and get it right the first time. But that's not really the point. The point is to practice the process of TDD on a problem that's small so that you've got the rest of your brain available for thinking about the process. Then at the end, the conclusions, it's usually wise to just save 2 to 5 minutes at the end of the session so that people have time to then, after they've written some code themselves, think about what happened and what they're taking away from the session. So that's what they're going to write on their note, what their takeaway is. And there's no need for you to actually comment or do anything with those notes. It's for them. And it's a sign for you, though, if they've written hopeful things, that maybe they're interested to learn more. And you could come back for another learning hour later on with more complex TDD problem to work on.